to one and all. I am Dr. Sumitra, an Associate Professor from the Department of Computer Science and Engineering. Today, we are all going to discuss about the virtual memory. The virtual memory is a technique which separates your user logical memory from the physical memory. The benefits of your virtual memory is all about only a part of the program needs to be in a memory for execution, and the logical address space can be much larger than the physical memory. Hence, it allows a memory sharing between the processor, enhancing your processor's creation efficiency and supports your running more program concurrently. Reduces also the need of your input and output operation when we have a spark and the loader. The background of this is all about the virtual address space. The logical view of a memory for the process starts from the address 0 and goes on to the end. The physical memory is organized into a page frames, and MMU, that is your memory management units, maps the logical to the physical address. The virtual memory implementations with the two major techniques, one is demand paging and the demand segmentation, which always focus on this given discussion. The virtual memory virtualization is here is a diagram that will illustrate you about the virtual memory. How does it work? The programs, the logical address are translated into the physical address via your MMU, and even if the physical memory is much smaller, the system goes on an illusion of the larger memory using a virtual memory. The page of the memories are stored in a secondary storage and fetched as needed. The data structure which enables on this will divides your memory layouts of the process like text, data, heap and the stack. The text is all about your program code, and the data is your global variable, and a heap is dynamically allotted your memory, and the stack is a function call and the local variable. This is the logical view which the virtual memory helps to manage your efficiently. The demand paging. The next is all about the demand paging. Rather than by loading your entire process into the memory, the pages are loaded only when needed. The advantages of these are it reduces your input and output. Obviously, it saves your memory spaces and faster response time. The steps which involved in this is where an MMU detects your missing page and triggered when we have a page fault. Requires a page which is fetched from the secondary storage, and also introduce your page table and how it is validate the bits, which helps in identifying the loaded pages. The basic concept behind this virtual memory is where in a swapping, the OS guess which keeps your pages to keep. In a demand paging, only required pages are brought in. If the required page is already in the memory, there is no difference. If not, the page fault occurs and the OS loads your pages. The MMU will need new logic for a supporting demand paging, where we have a valid, invalid bits. Every page table entry has valid and invalid bits. V is your page in a memory, and I is not in the page is not in the memory. Helps the MMU detects your page faults, and this diagram that shows you an example of the page table and some pages which marked or invalid. So the page table with the page are not in the memory, hence it illustrates how some pages are in memory while others are in the secondary storage. MMU uses your page table to determine whether the page access should be redirected to the storage, facilitates on-demand loading of your pages. The page fault will also occur when the request page is not in the main memory. The OS must have to detect your page faults, locate at a free frame, and schedule disk operations to load pages and update your page table, restart the instruction that caused your faults. Stepping into handling your page fault, this diagram also shows you how your page fault handling mechanism. The program accesses the page with the MMU, traps to the OS, and the OS will load your page from the disk and updates your page table and resumes the progress execution. Hence, it demonstrates how your demand paging is implemented at the low level. Hence, I summarize this virtual memory and the demand paging. The virtual memory is always a program without loading your entire process into a RAM, and it enables a larger logical address space, supports the sharing and improves efficiently. and implemented using your demand paging. Load pages only when needed, reduces the memory and input and output storage. MMU will always translate the logical to the physical address. Use a page table with the valid and the invalid bits to track your page status. The page fault occurs when the page is not in the memory. Hence, the OS will loads it from the disk and updates the page table. I hope you are clear with this concept. Thank you one and all.